Good afternoon to all. I am Dr. B.G. Geeta, Professor, Department of Computer Science and Engineering, K.S.Rangasamy College of Technology, Tiruchengodu. Today I am going to uh, speak about data science 51 CS 701, decision tree, clustering, dimensionality, reduction topics. A decision tree is a supervised machine learning algorithm used for classification and regression tasks. It models decisions and their possible consequences in a tree, like a structure. It supports a hierarchical model that uses a tree like models of decisions and their possible consequences, including chance, event outcomes, resource cost, and utility. The structure of the decision tree contains root node, internal nodes, branches, and leaf nodes. A root node represents the entire data set and the initial decision to be made. Internal nodes represent decisions or tests on attributes. Each internal has one or more branches. The branches represents the outcome of a decision tree or test leading to another node. The final one is the leaf node, represent the final decision or prediction. No further split occurs at these nodes. This is the structure of the decision tree. The decision node is the root node and the decision node is a subtree, and after that there is leaf nodes available. Why we use decision trees and how it works? There are various algorithms in machine learning. So choosing the best algorithm for given data set and problem is the main point to remember while creating a machine learning model. There are two reasons for using the decision tree. First, decision tree usually mimic human thinking ability while making a decision, so it is easy to understand. The logic behind the decision tree can be easily understood because it sorts like a tree structure. In a decision tree, for predicting the class of the given data set, the algorithm starts from the root node of the tree. This algorithm compares the values of the root attribute with the record attribute, and based on the comparison follows the branch and jumps to the next node. For the next node, the algorithm again compares the attribute value with other subnodes and move further. It continues the process until it reaches the leaf node of the tree. There is a procedure. Step 1, begin the tree with a root node, says yes, which contains the complete data set. Step 2, find the best attribute in the data set using attribute selection method ASM. So easily select the best attribute for the nodes of the tree. There are two popular techniques for ASM. One is information gain, another one is Gini index. Divide the S into subsets that contains possible values for the best attributes. Generate the decision tree node which contains the best attribute as a next step. The step 5, rigorously make a new decision trees using the subset of the data set created in step 3. Continue this process until a stage is reached where you cannot further classify the nodes and the final node is as a leaf node. This is the procedure. So what is information gain? Is the measurement of changes in entropy after the segmentation of a data set based on an entropy. So entropy is a metric to measure the impurity in a given attribute. It specifies the randomness in data. Entropy can be calculated as entropy of S equal to minus P of S, that is probability of S, log to P of S, probability of S, minus probability of no, log to P of probability of no. It calculates how much information a future provides us about a class. According to the value of information gain, we split the node and build the decision tree. The decision tree algorithm always tries to maximize the value of information gain, and a node or attribute having the highest information gain is split first. So information gain equal to entropy of S minus weighted average into entropy of each feature. Genetics is a measure of impurity or purity used while creating a decision tree in the CART, that is classification and regression tree algorithm. An attribute with a low Gini index should be preferred as compared to the high Gini index. It only creates binary splits and the CART algorithm uses the Gini index to create binary splits. Gini index can be calculated 1 minus summation of j p of pj square. Advantage and disadvantage of decision tree. Advantages: it is simple to understand. It follows the same process which a human follow while making any decision in a real life. It can be very useful for solving decision related problems. It helps to think about all the possible outcomes for a problem. There is a less requirements of data cleaning compared to other algorithms. Disadvantages: it contains lot of layers which makes complex. It may have an overfitting issue which can be resolved using the random forest algorithm. For more class tables, the computational complexity of the decision tree may increase. The next topic is clustering. Clustering aims at forming groups of homogeneous data points from a heterogeneous data set. It evaluates the similarity based on a metric like Euclidean distance, cosine similarity, Manhattan distance, and then group the points with the highest similarity score together. The task of grouping data points based on their similarity with each other is called clustering or cluster analysis. This method is defined under the branch of unsupervised learning, which aims at gaining insights from unlabeled data points. The clustering aims at forming groups of homogeneous data points from a heterogeneous data set. This shows the diagram. So uses of clustering. First one is market basket analysis. Shop owners analyze their sales and figure out which items are majorly brought together by the customer. Market segmentation. Business uses clustering to group their customers and targeted advertisement to attract more audience. Social network analysis. Social media sites use your data to understand your browsing behavior and provide you with targeted friend recommendations or content recommendations. Then medical imaging. Doctors use clustering to find out diseased areas in a diagnostic images like X-ray scans. Dimensionality reduction. It is a technique used to reduce the number of features in a data set while retaining as much of the important information as possible. High dimensional data refers to data with a large number of features or variables. Dimensionality reduction can help to mitigate these problems by reducing the complexity of the model and improving its generalization performance. There are two approaches. One is feature selection and feature extraction. Feature selection involves selecting a subset of the original features that are most relevant to the problem at hand. Feature extraction, it involves creating a new features by combining or transforming the original features. Thank you.